So chapter 6. Chapter 6. Most of this lesson, let me take a look at it. Now, we are going to do a little bit of math in here, okay? But the first part of it anyway, oh yeah, we're going to do some good math in here. Pythagorean, distance formula, remember distance formula, right? We've done distance formula before. We're going to use it again. So it says classifying quadrilaterals. So the first part of this is just vocab, just knowing one of these words are. First of all, let's talk about the first word, and it's quadrilateral. We've mentioned this word before. Judah. We've mentioned this word before. We've talked about it. Basically, off the top of your head, tell me what you know about something that's a quadrilateral. Quad meaning what? Four. So four what? Four sides. That's right. So it's a polygon. You may not have remembered that word, but it's a polygon with what? Four sides. Okay? So any closed figure with straight sides that has four sides, that's a quadrilateral. I'm going to talk about a couple, before we actually get into actual quadrilaterals, we have to mention something else that's very important because we're going to use these words a lot. Okay? Look at this side. Let's call this ABCD. ABCD. Let's take a look. Look at AD and look at BC. Everybody see that? I'm going to make it a different color. All right. See those two sides right there, the two blue ones? We call these sides opposite sides. That shouldn't be too hard to figure out, right? Because they're across from each other, okay? Now, you don't have to write this down because I will talk about this in a second. Yep. These are opposite sides, okay? So the blue ones are opposite, and let's make this yellow if I can. Come on. There we go. All right. So the blue ones are opposite sides, and the what? Yellow. The yellow ones are opposite sides. All right, so opposite. I know you can't write blue and yellow on your notes, but you get the idea. So AD and BC are opposite sides, and AB and DC are opposite sides. It's important because we're going to use that when we talk about some other stuff. All right, it's not that hard. It's not the main gist of this, but you get the idea. All right? Uh-oh, what's that thing? Oh, I know why. Because I didn't do that. There we go. All right. Let's talk about... Let's turn these back into white. Let's turn these... Tell you what, I'm going to turn just that one back into white. And I'm going to make this one blue. All right, now let's take a look at these two. Look at these two right here. Those two blue ones, AB and BC. Are they opposite sides? Are they opposite each other? No, they're right next to each other. We have a word for it. I don't know if you remember the word that we used, but we use this word. So these ones right here, they're called consecutive. Yeah, you remember that word, don't you? Remember we talked about consecutive interior angles and all that kind of stuff? That means they're right next to each other. So AB and BC are consecutive sides. There are other consecutive sides here. I didn't show all of them to you. So what would be another pair of consecutive sides? Like AD. What would be a side that's consecutive side with AD? Say it. DC, right. AD and DC. They would be consecutive sides. Any two sides that touch each other, basically, okay? Right? So these two touch right here. These two right here touch right there. These would be consecutive sides, right? These two. These two touch right there. Those two are consecutive. And these two are consecutive. Those are supposed to be arrows, okay? So these two sides right there are consecutive. All right, enough of that. Let's get rid of all that mess. Yeah, basically the ones that are next to each other. That's how I like to think of it, okay? They're consecutive. Let's go back to this and just make everything white again. Come on, there we go. All right. Now, let's talk about some angles. Take a look at angle D and angle B. How do you think I'm going to name those two angles right there? What are they? They're not corresponding because they're not next to each other. They're completely what to each other? They're opposite each other. That's right. See? See how they're across from each other like this? So they're opposite angles. So angle D and angle B, or angle B and D, they're opposite each other. Give me another pair of angles that are opposite angles here. A and C. All right, so A and C would be opposite each other as well. Okay? What about angle A and angle B? Are they opposite each other? No. They're next to each other. What word do we use when they're next to each other? They're consecutive, okay? Sometimes we use the word adjacent, but we're not going to use it right now. We'll use it for something else, okay? But on this one, we're going to call them consecutive angles. So A and B are next to each other, they're consecutive angles. What else is a consecutive angle with A? A and D. A and D would be consecutive. All right, what else with D? D and C, and then C and B. Everybody see that? So these two angles are consecutive, these two, these two, these two. They're opposite. The B and the D are opposite, the A and the C are opposite. They're the only two opposite angles. Okay, but there's 4 sets of consecutive angles. Everybody good with that? All right. And because we're going to use those words later on. All right, enough of that. We haven't even really started talking about the quadrilateral yet. We've just been talking about the sides and the angles. Now let's actually start talking about the types of quadrilaterals. So that's what I wrote in my notes. So I'm going to write it right here. The types of quadrilaterals. So these are kind of special. They're not just ordinary, everyday quadrilaterals. All right, they're special quadrilaterals. The first one that we're going to talk about this a lot later on. Okay, this is a big, big deal. That's probably why they put it first. All right, and that's not it. I'm going to do something to it. I'm going to hit transform. I'm going to come over here and let's make it like 20. Okay, so that's what I want right there. That thing right there. First of all, is it a quadrilateral? Yeah, because it's got what? It's got 4 sides, okay? But a quadrilateral is very general. A quadrilateral could look like all kinds of different things, right? As long as it's got 4 sides, it's quadrilateral. But this is really specific. This one has, I'll show you, and you probably remember this. It's been a while since we've done this, but what if I put a little arrow right there and an arrow right there? What does that mean? They're parallel to each other, okay? It doesn't mean they're equal to each other, okay? Doesn't mean they're equal, okay? But it means that they're parallel to each other. So if I said that these 2 sides were parallel to each other, and one other thing, that's not enough, okay? Just saying that one pair of sides is parallel is not enough. If I said that these 2 are parallel to each other, what does that mean to be parallel, by the way? They're never going to do what? They're never going to touch. They keep on going. All right? Everybody see that? So the one arrow means that these opposite, again, we just talked about this, right? So these 2 opposite sides are parallel, and the other 2 pair of sides are parallel to each other. All right? That's why we just learned about opposite sides. So when you have both pairs of opposite sides of a quadrilateral parallel, then this thing is a parallelogram. Have you ever heard of a parallelogram? Now you have, okay? So it's a parallelogram. Why is it a parallelogram? First of all, it's got 4 sides, and the opposite sides are parallel to each other. Just jot that down. The opposite sides are parallel. Okay? Everybody understand that, right? So that's a parallelogram. We're going to learn a lot more about parallelograms later on. All right? But we're just defining it right now. That's all we're doing. We're just saying what a parallelogram is. Everybody good? The next thing, I bet you every single person in here, when I draw it, you can tell me what that is. Right there. That's my drawing right there. It's a rectangle, exactly right. But there's got to be some stuff that is true about this. We'll stick with the pink. We'll go in color coordination here. So in order for it to be a rectangle, you probably already know. What do you think must be true if it's a rectangle? 4 sides, we know that, okay? But what's special about this 4-sided figure makes it a rectangle? Say it again. They're even? You're like whispering. I can barely hear you. The sides are not even. Is that what you said? Okay, they're not all equal to each other. Is that what you're trying to say? Yeah, they're not. Okay, all 4 sides. Well, actually, they could be all equal to each other and still be a rectangle. All right? Somebody else, think about a rectangle. Look at it. Look at the angles. I'll give you a hint. Look at the angles. What do you think is true about the angles of this thing? Silas, what are you going to say? The right angles. They're right angles. And what does a right angle mean? They're how many degrees? 90 degrees, okay? So how do we show a right angle? Put that little box. And we've done that before. That's not new, right? We've talked about right angles before. I think we have, haven't we? In here? Yeah, I'm pretty sure. All right, so if all 4 angles are right angles, then we didn't say anything about the sides, did we? Okay? And the definition of rectangle doesn't say anything about the sides. So, Amaya, you said that they're uneven or they're not equal to each other. That really has nothing to do with it being a rectangle. Because you could have all 4 sides equal to each other, all right, and it still be a rectangle. We'll talk about that in a minute. Okay? So, this is, I'll write it down. So, it's a rectangle. What's that? All right, well, deal with it. So it's a rectangle, is a parallelogram. All right, so it's a parallelogram. A rectangle is actually a parallelogram with what? 4, what is it? Right angles. Okay, so a rectangle is a parallelogram. So what did we know about a parallelogram? What did we know about the opposite sides on a parallelogram? Don't let that shut all the way. Let it just, there you go. What do we know about the opposite sides of a parallelogram? They're parallel to each other. So what's true about the opposite sides of a rectangle? They're also parallel to each other. Why? Because a rectangle is a parallelogram. Okay? Now, is every single parallelogram a rectangle? No, because look, this is a parallelogram. Is that a rectangle? No, because the angles are not right angles. But is every single rectangle a parallelogram? Yes. Okay, it's by definition. A rectangle is a what? It's a parallelogram. So every single rectangle is a parallelogram. But it's special. It's a special type of parallelogram. What's special about it? All the angles are right angles. Well, there's 4. There's always going to be 4 if it's a quadrilateral. But all 4 angles are what? Right angles. You with me so far? Okay. I'm trying to go slow for you so you keep up and you don't get too confused. Because we have 1, 2, 3, 4, 5, 6 different ones we're going to do. Okay, we've done 2 already. So we've got 4 more to do. Everybody ready? All right, let's do another one. Everybody's got this down, right? Make sure you write them down. So now what we're going to do is I'm going to change this a little bit, so don't get too excited about knowing what this is. All right, and I don't know if it's perfect, but I'm trying to make it as close to perfect as I can. So that's pretty close. So it kind of looks like a what that we've already talked about today. Looks like a parallelogram, but I tried to make it so this was true. So let me go to pink again, keep our color. So watch. If that side and that side are equal and equal to that and that. So all 4 sides are equal to each other. I didn't say anything about the angles. Okay, I don't know anything about the angles, but I do know that all 4 sides are equal to each other. So it's a 4-sided figure. All 4 sides are equal to each other. This is a word that maybe in passing that you've heard before, but maybe some of you haven't heard at all. All right, so this one might be a little unusual to you, and it's called a rhombus. Have you ever heard of that? A A rhombus. You may not have studied it. When you're a little kid learning your shapes, you know what a circle, a square, rectangle, triangle, and all that stuff is. They probably were not teaching you rhombus, all right? But now that we're not little kids, now we're going to learn it. So it's a rhombus. Notice how to spell it. R what? H. It's kind of weird. I don't know why. English language sometimes, really weird. But R-H, okay, O-M-B-U-S. The rest of it sounds normal, but they put an H in there. R-H. Rhombus. I don't know if people pronounce it like that. Rhombus. That would be kind of silly, wouldn't it? So we just say rhombus. All right. Now, what is a rhombus? Well, a rhombus is also a parallelogram. It looked like it at the beginning, didn't it? But it's a parallelogram. And what's special about this parallelogram? It's got what? A parallelogram with four what? Equal. Are you just saying that just to get on my nerves, or are you just... Yeah, but think before you speak. There's no way there's four right angles, all right? These are what? With four equal sides. It's not the same difference, all right? There's no right angles in here at all, so it's not the same difference. So a rhombus is a parallelogram with four equal sides. Now, since it's a parallelogram, what do we know about the opposite sides? They're equal to each other, but they're also parallel to each other. So these two are equal because it's a rhombus, but they're also parallel because it's a what? Parallelogram, okay? So these two are parallel and these two are parallel. I didn't write it on there, but anything we know about a parallelogram is true about a rhombus. All right, now we're getting somewhere. So we add a four-sided figure with four right angles. We add a four-sided figure with four equal sides. Here's something that you did learn as a little kid. Well, you didn't probably hear this definition for it, but what is a parallelogram with four right angles and four right sides? What do you think that's going to be? It's going to be a square. Very good. Okay, it's going to be a square. So there it is, right there. All right. Judah, do you need to leave? So watch. So if you have four equal sides and at the same time you have four right angles, then what do you think we call this thing? We call it a square. All right? So you could call a square something else that we've already learned. Amir? You could call a square something else that we've already learned. Here's a four-sided figure with four right angles. What did we learn just a few minutes ago, about a four-sided figure with four right angles? What was that? It was a rectangle. So what is a square? Square is also a rectangle. Now, when you're a little kid, you wouldn't look at this and say, oh, that's a rectangle, would you? Okay, you would something that's a little longer, right, on two sides. Okay, but technically, in geometry, a square is a rectangle. So every single square, no matter how big, no matter how small, is always a rectangle. So our definition is a square is a rectangle with four equal sides. Okay? Or, here's another way you could say it. You could say it's a rhombus. What does a rhombus mean? It's got four equal sides, correct? So this does have four equal sides, but what's true about this rhombus? It's a rhombus that has what? Four equal angles. Or let's not put equal, let's put right. Okay? Or if you wanted to, you could call it a parallelogram. I might be confusing you at this point, so I apologize, but for those that can follow, it's a parallelogram with what? With four equal sides and what? Four what? Right angles. Okay? You could look at it as either one of those definitions. It might be a little too much information for you, but that's okay. I think you can handle that, can't you? So a square is a bunch of stuff, isn't it? It's not just a square. It's a rectangle, it's a parallelogram, and it's a quadrilateral. All right, so I could call a square a whole bunch of stuff. So squares are pretty important. Do you have a question? Yeah. All right, we got a couple more. How many say we're doing? 7? 6 or 7? Something like that. Did I say 7? I think I said 6. What have we done so far? 1, 2, 3, 4. We've done 4 so far. Now, on a nice spring day with a nice breeze, maybe you want to bring one of these things out. What do you think I'm going to say?
Stop signs.
If I go outside and it's nice and breezy, that's the key. It's nice and breezy outside.
Oh,
a coat? No, it's not cold. It's not cold. It's warm. You're going to do something that's kind of fun.
a kite.
A kite. Very good.
Oh, yeah, bar.
Okay. So, now, we've talked about all the parallelograms. There's no more parallelograms to talk about, okay, at least in this list. All right? So, this is not a parallelogram. All right? If you look at it, look at the opposite sides. Do they look? I'll tell you what, I'm going to extend this a little bit just to make it look a little more obvious. And let's take this to here. And let's take this to here. All right. Do the opposite sides look equal to each other here? Or do they look parallel to each other? That slants this way. This slants a lot different, doesn't it? Okay? There's no way that they're parallel. What about this one and this one? No, they're not parallel. So it's not a what? It's not a parallelogram. Okay? So it's definitely not a parallelogram. But it is quadrilateral. What does that mean? Quadrilateral. It's got what? 4 sides. In fact, you know what I'm going to do? I'm going to get rid of that middle one. I'll just keep it like that. We will put that middle line in there later on when we talk more specifically, because we're going to actually learn some theorems that are specific about a parallelogram, specific about a rectangle, a square. What was the other thing we did? Rectangle, square, rhombus. Okay? We're going to have theorems that talk about those specifically, and then we're going to put that line in the middle like that. And actually, we're going to put a line right here and a line right there. But for right now, we're not going to do that. All we're doing is just learning our shapes. That's all we're doing today. All right? We may not even do any math. Maybe we'll do a little bit of math today. All right? So here we go. Let's talk about what a kite is. First of all, a kite, let's write it down first of all. Kite. It's a quadrilateral. Now, I am going to write this down. It's a quadrilateral. Don't worry about the lines in the middle. I'm not even going to deal with those right now. We will later on. So what's it got? It's got 2 pairs of equal, and here's a word that we started this class off with, consecutive sides, but, we'll underline that, the opposite sides are not equal. But let's put, put whose opposite sides. Whose opposite sides are not equal. Usually we say stuff is equal, but this time they are not equal. Now, what in the world does that mean? That's a lot of words. Okay, it's a little confusing when you first read it. If you read it real fast, you're like, I have no idea what that means. All right, but let's take a look. We'll break it down. 2 pairs, okay? You have 2 pairs, so that means how many sides? 4 sides, right? 2 pairs. 1 pair is 2, a second pair is another 2, that's 4, okay? So you got 2 pairs of equal consecutive sides. What does that mean, consecutive? They touch, right? This one and this one are consecutive sides. Everybody see that? So it's got 2 pairs. Does it mean that every single consecutive side is equal? No, it's got 2 pairs that are equal. So the ones right here, this left one and right one right there, they are one of the pairs that are equal to each other. Where's the other pair that are equal to each other? this other one down here and down here. You see that? So I'm going to put 2 tick marks just to show that the ones with 2 tick marks are equal to each other. The ones with 1 tick mark, they are equal to each other. Everybody good? All right. So that's the first part of it. It says 2 pairs of equal what? Consecutive sides. This side and this side are consecutive. They're not opposite. This side and this side are consecutive. They're not opposite. But do all the consecutive sides, are they all equal? No. If all the consecutive sides were equal, that means all 4 sides would be equal. That's not true here on a kite. What's the second part? It says whose opposite sides are not equal. So look, this side right here and this side right here, they are opposite each other. It's true, they are opposite, but are they equal to each other? No, because this got 1 tick mark, this got 2 tick marks. That means they are not equal to each other. So the sides opposite are not equal. That's the definition of a kite. It's a little weird, all right, but that's what it means. It's a quadrilateral, 4 sides, and it's got 2 pairs of consecutive sides that are equal to each other. So these 2 are equal, these 2 are equal, these 2 right here opposite are not, these 2 opposite are not. We're going to learn a little bit later, I keep saying this, but we're going to learn a little bit later more about a kite. And but we're not going to do it today. Last one. 6 minutes. Good timing, actually. What do you mean you actually did stuff today? You actually do stuff every day in here. What? Do I watch it? I have watched it. I don't watch it often. I've watched it one time. And the only reason I watched it is because everybody was making such a big deal about it. And I was like, all right, I got to see what this thing is. Because my kids were already grown up, way grown up by the time Frozen came out. No. So here we go. Let's do this. Good try. I don't know why you're trying to keep me off track because I'm not going to. All right, this thing right here is called a trapezoid. This is another one that, they don't teach you when you're a little kid. All right, I don't know if anybody's heard that word before. Has anybody never heard the word trapezoid? Okay. So what in the world is a trapezoid? Well, I'm glad you asked. Here it is. It's a quadrilateral, because these are all quadrilaterals. Okay, it's a quadrilateral with exactly 1 pair, see 1 pair, just 2 sides, and that's it, of parallel opposite sides. All right. That shouldn't be too hard to figure out. It's a quadrilateral, 4 sides. Does this thing have 4 sides? Yeah. It says exactly 1 pair of parallel opposite sides. Now, I tried to draw it so it's obvious which ones are parallel to each other. Which ones do you think are parallel to each other here? The bottom and the top. Yep, the top and the bottom. It looks like they're parallel to each other, right? So if they were parallel and these 2 here were not parallel, what does that make this thing? If you have exactly 1 pair of parallel sides, what is this thing? It's a trapezoid. That's right. It's right there in front of you. Okay? It's a trapezoid. All right? Can both pairs of sides, can this one and this one be parallel? No, because if it was, then it would be a what? No. It'd be a parallelogram. It would be a parallelogram. Okay? It could be a square. It could be a rectangle. But more generally, it would have to be a parallelogram. So a trapezoid is not the same thing as a parallelogram. A parallelogram has both pairs of opposite sides parallel. Okay? But a trapezoid only has what? Just 1. The 2 Judas. I'm going to separate you about any second. He's not even listening to me. He's talking so much, he's not even listening to me. Did you even realize that? It's like kindergarten in here. All right. So let's talk a little bit about some of these words right here. The 2 sides that are parallel to each other, we call the bases. All right? We'll call that base 1 and base 2. Doesn't matter which one's 1 or 2. Oops. So the two sides that are parallel we call the bases. The two sides that are not parallel, and you'll always have on a trapezoid two sides that are not parallel, okay? The two sides that are not parallel are called the legs. So, well, I'll just put leg for that one and leg for this one. That's important for what, we're going to talk about a little bit later on. Now, what I'm going to do is I'm going to draw a special, this is not a new thing, but this is a special type of trapezoid. So let me try to draw it. And we're going to be talking quite a bit about this particular, let's see what I want to do this. I'm going to try my best to make it accurate. All right. What do you think I tried to do here? Well, these two are parallel because it's a trapezoid. But what do you think I tried to do to this side, this leg and this leg? Tried to make, not parallel, they're definitely not parallel. Make them equal to each other, right? Okay, I tried to make them equal, all right? So, watch this. If this is parallel to this, and this length is equal to this one, we actually used this word before. Remember we had a triangle with two sides equal to each other? Do you remember what that was called? Isosceles. We call it an isosceles triangle. So, check this out.
I said parallel. You said it was wrong.
Correct. You're right. It is wrong. All right. So look, if you had a triangle with two equal sides that are equal to each other, that's called an isosceles triangle, right? Well, this is kind of, a trapezoid is kind of like it's got a lot of similarities to a triangle. Watch. If I extended that up to here and this up to here, what would it look like? It would look like a triangle. It's basically like a triangle, but I just took a knife and I just cut it nice and flat. All right, cut off the top of the triangle. Can you visualize that? So a triangle and a trapezoid have a lot of similarities to each other, and they have this similarity as well. If two sides are equal to each other on a trapezoid, the two legs, I should say, okay, the two non-parallel sides, if they're equal to each other, I call this, what do you think? An isosceles, not triangle, but, say it, Neil, trapezoid. All right, so an isosceles trapezoid is a trapezoid with two equal legs. All right? All right, I only got a minute left, so I am not going to try to do the example. But we'll just leave it right there, okay? So that's 6-1. Maybe we'll hit a little bit more of that tomorrow. So I'm not going to give you any homework on this because we've only learned some words, okay? We haven't learned like how to do anything, any math or anything like that. So the bell has not rung yet, so you need to stay in your seats, okay? I didn't say you could stand up. Silas, have a seat. No, that's not a seat. Silas, that is not a seat. No. Walk around, please, and stay in your seat that was assigned to you. All right? Was that the seat you were sitting in? You sure, or was it the back one? I'm just asking you a simple question. I was very kind to you. You don't have to call me bro. Silas, look at me. Look at me. You're not looking at me. Look at me. Don't ever call me bro. You understand? It's not what we do here. Okay? I'm not your bro, not your friend. I'm your teacher. Okay? I just asked you something simple just to sit down. We don't need to go through that.
Yes, sir.